Okay. Trig identities, 10C. What is an identity? It's an equation that is true for all values. That is true for all values. For example, x plus x equals 2x. No matter what x value I put in here, this statement is always true. X times x equals x squared. No matter what x value I put in here, it's always true. 2 times x plus 3 is equal to 2x plus 6. It is. So we have trig identities, and so the trig identities, you are familiar with some of them. We started off with sine of x over cosine x is equal to tangent of x, as long as cosine of x doesn't equal 0. We also saw in the last unit the Pythagorean identities. And so let's remember, we had our unit circle. This was sine of theta. This was cosine of theta. This was 1. And so we were able to create sine squared theta plus cosine squared theta equals 1. And then if you recall from last unit, I divided this equation by sine. And so I got, dividing by sine squared theta, I got 1 plus cotangent theta equals cosecant squared theta. Or if I divided the equation by cosine squared, dividing by cosine squared theta, this one I got tangent squared theta plus 1 equals secant squared theta. And so, once again, these are identities. They work for all the values. So, if you recall, so I could, the sine squared of 7 pi over 4 plus cosine squared of 7 pi over 4 equals, it equals 1. Because this is an identity. This always equals 1. What else? We also learned about the reciprocals. Well, it's here. What exactly are these? What is cosecant? What's cotangent? What's secant? Well, it's all identities. So cosecant theta is equal to 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangents. And if you recall, because tangent is sine over cosine, this is cosine theta over sine theta. And they could just manipulate all these things. What we're going to be doing over the, for this homework, is you're going to be proving identities. So how do we prove an identity? Well, you can prove a trig identity. There's several ways of proving this. They're going to say prove the trig identity first. So you're going to look at the statement. Here's our first one: sine to the 4th power theta minus cosine to the 4th power is equal to 2 sine squared theta minus 1. Okay, so how do we prove trig identities? Step 1: make a wall. Make a wall. So you're going to put a wall down here. Step 2, you're going to manipulate each side, but you're not going to send the values over from the left to the right. So manipulate each side. Manipulate each side. And so the idea is you're going to manipulate each side so that it eventually looks like each other. Well, I'm going to take care of the left side. I know sine to the 4th minus cosine to the 4th. Well, that's a difference of 2 perfect squares. And I'm going to get a little lazy here, forgive me. So I'm going to say sine squared plus cosine squared times sine squared minus cosine squared. Okay, I notice that this is 1, so I have sine squared minus cosine squared. And then what I'm going to do is we're generally going to use this Pythagorean identity. We saw how to manipulate it. So cosine squared, so sine squared, cosine, well, I want that sine squared. So you know what? I know that sine squared is actually 1 minus cosine. No, I apologize. Well, it's that, or cosine squared is equal to 1 minus sine squared. So over here, I'm going to write sine squared minus 1 minus sine squared, and I get 2 sine squared theta minus 1. You're done. You've manipulated the left side to look like the right side. You're finished. You are done when both sides look like each other. That's it. Shall we try another one? Yeah, let's try another one. Let's try another one. How about this one? Let's see. I want you to prove that 1 over cosine theta minus cosine theta is equal to sine theta times tangent theta. What do you think? That's weird. I don't know. You know what? So step one, draw the wall. Step 2, start manipulating both sides. Maybe I can't turn this into that, but if I bring them both down to something the same, then I've proven it's an identity. So let's see. How do I combine fractions? Well, I have 1 minus cosine squared over cosine. Because remember, I did cosine. If I add fractions, I need a common denominator. Let me manipulate this. I'm not sure what's going on here. Or you know what? I know what's going on here. 1 minus cosine squared is sine squared. So I have sine squared theta over cosine theta. Let's leave that. Because I brought it together, I simplified it. Now let's see what I can do over there. Another trick of proving identities is first turn everything into sine or cosine. Here's another rule. Rule 4, try to turn everything into sine or cosine. That will help you. So let's see. You know what? So I have sine theta times sine over cosine. You know what? Sine squared over cosine theta. I'm done. Because I made the left look like the right. And you're done. Finished. And you've proven that 1 over cosine minus cosine is equal to sine theta tangent theta. Why do we need this? Well, this might be a simpler representation of this expression. And so we know in the next subunit where I'm going to ask you to solve an equation, if I say 1 over cosine minus cosine is equal to 0, I might want to turn it into this first, or I might want to turn it into one of these other expressions. I think that's it for 10C. Let's see. Shall we try another one? Okay, here's another one. Oh, sorry, I just went to the bathroom. Here is another one. Try this one. Let's see. Sine theta times cosine theta is equal to tangent theta divided by 1 minus plus tangent theta. So try that one on your own. Let's see. Think about it. Okay, now we're back. First, draw the wall. Second, try to simplify this. So immediately you have to start recognizing these identities. They show up everywhere. Just remember that. Sine squared plus cosine squared is 1. Divide by sine to get 1 plus cotangent squared equals cosecant squared, or divide by cosine to get tangent squared plus 1 equals secant squared. Just, get these down. You'll have them on the formula sheet. So you immediately, I'm seeing, you know what? There's secant. So the first thing you want to do is, I'm going to leave this as sine cosine. We're going to be talking about another identity in other units. But right now we're going to leave this as it. Let's attack that. So let's see. I have sine theta over cosine theta divided by, divided by secant square theta. Well, this is sine theta divided by cosine theta divided by 1 over cosine squared. So this ends up being sine theta divided by cosine theta times cosine squared, which is equal to sine theta, cosine theta. We have our identity. So this is their way of getting you to do a lot of algebraic manipulation with trig identities. It's a thing, they like it. What else are they interested in? You should know how to represent one function as another function. So for example, they will say, and I this is a problem out of the book, I believe it's number 7 in 10C, they will say if the tangent of theta equals t, and then they're going to ask you a couple of it, they're going to say, what is cosine theta? What is sine theta? What is cosine squared? Let's see, cosine squared theta minus sine squared theta, and they're going to ask you 2 over sine theta plus 1. So I want you to think about these. Think about this. So there's 100 ways to do these. My favorite way, let's use the identity. So you see tangent theta, you see cosine theta. You don't know cosine, but you say, oh, you know what? Tangent squared and secant squared are connected. So let's start with the first one. So we know that tangent squared plus 1 equals secant squared theta. So that means that if tangent is t squared plus 1 equals secant squared theta. Therefore, cosine squared theta is 1 over t squared plus 1. Okay, well, what's sine squared theta? Let's see, sine squared theta. Well, what do I have here? Same idea. You don't know that tangent is related to sine, but you know that cotangent is related to cosecant, right? So I'm going to write that down. Cotangent of theta plus 1 is equal to cosecant theta. So I know that 1 over t squared plus, how about t squared over t squared is equal to cosecant squared theta. And so I have t squared, 1 plus t squared over t squared equals cosecant theta. So I know that t squared over 1 plus t squared is equal to sine squared theta. Was that the only way to do it? No. You could have subtracted this. You could have said, I mean, that's one way, right? Or you could say, hey, Mr. Rather, if you know cosine squared, right? So 1 plus, you could have said, you could have said, or you could say that sine squared plus cosine squared is equal to 1. So sine squared is equal to 1 minus 1 over t squared plus 1. So this is equal to t squared plus 1 over t squared plus 1 minus 1 over t squared plus 1. Final answer, t squared over t squared plus 1. It's just a lot of manipulation. It's another way to IB and the math, everyone, to get you manipulated some more. let's try, well, we're done. So the next one is cosine squared minus sine. So let's see, what do we have here? So let's try that one. So cosine squared minus sine squared theta, and you put them together. So you can try these on your own. This is part of the homework. Personally, my favorite way of doing these is, I'm going to show you my way. Ready? So let's erase this. And let's go to do. If tangent of theta equals 2, make a picture. If this is theta, and we're told that the tangent of theta is t, I'm going to first rewrite this t over 1. That means opposite over adjacent. And that means from the Pythagorean Theorem, we have the square root of 1 plus t squared. And once you have your diagram, you can find everything else you need. You can find sine of theta, which is t over the square root of 1 plus t squared. You can find sine squared of theta, which is t squared over 1 plus t squared. If you have your sine, you can also find your cosine, and you can find your secant squared, and you can find your cotangent squared, and all the combinations. So this is the algebraic way. Personally, I like the geometric way. The second someone gives you tangent theta is a variable, make a diagram. It will make your life easier. What's the last thing I want to talk about? I think that's it. I think we're good to go. Okay, tensei.